All right, guys, it's time for our very last live stream before the Algebra 2 Regents this year. So in this video, we're going to talk about the modeling questions, and that is questions where they're asking you to look at real-world scenarios. Big topics for this are going to be exponential and log equations, trig equations, probability statistics, regressions, and some other things we'll see along the way. So let's dive right in. So number one, which scenario can be modeled by an observational study? Now the key here is that this says observational. So it is not a survey. We are not asking people questions. It is not a controlled experiment where we have a control group. It is just purely through observation. So let's take a look. For the first one, in a class project, we're asking every 10th student entering what they eat for breakfast. I am not observing, I am asking. That's a survey. B, a social researcher wants to learn whether or not there is a link between attendance and grades. She gathers data. All she's doing is observing what's going on in those districts. So I'm going to guess my answer is B, but let's read through the other two. A researcher wants to learn whether or not there's a link between children's daily amount of physical activity and their overall energy. During lunch, she distributes a questionnaire. That tells me that is a survey, so it's not that. And 60 seniors take a course in advanced algebra, are randomly divided into two classes. One uses a graphing calculator, the other never does. I see a control group. It is definitely not that. So again, with observational, you're looking for something that you've just observed. Okay, let's go to the next one. The weight of a bag of potatoes at Hannaford averages 8 pounds with a standard deviation of 0.5. The weight of all the bags of potatoes closely follow a normal distribution. Determine what percentage, so my answer should be a percent, of bags to the nearest integer, that's going to be a number without a fraction or a decimal, weigh less than 8.25. So let's take a look at this. I'm going to draw my curve. 8.25 should be about here because 8 is my mean, and it's just above that. And this would be a half of standard deviation above the mean. Now, you could figure out what that is, but I know I want to know how many weighed less than 8.25. So I am going to shade my picture here. And that helps me really understand what I want. So if I think about lower, upper, and then mu and sigma, and remember we're just going to put these into our calculator, I can tell here that this 8.25 is my upper. Now, my calculator does not know that I'm talking about potatoes. It doesn't know that I'm talking about numbers that can't be negative. So what I'm going to put in here is actually negative infinity, or as close to it as I can get, which is negative 9999999, right? And then mu and sigma are our mean and our standard deviation. They tell me the mean is 8 and the standard deviation is 0.5. When you put that into your calculator, get 0.691462467 and rounded to the nearest integer percent, that would be 69%. Now, remember here that if you're stuck on how to actually do that on the calculator, you can go back to my calculator video. Okay, another modeling problem. In New York, the minimum wage has grown exponentially. In 1996, the minimum wage was $125. I'm going to guess that that's sort of my initial here. And in 2015, notice that that is 9 years later. Keep that in mind. Or I'm sorry, 19 years later. The minimum wage was $8.75. Determine the rate of growth to the nearest percent. So this does not say it's growing continuously. It also doesn't say that it's growing any certain number of times per year. So I'm just going to use A1 plus R because it's growth to the T. So I know that my initial was 125. It's growing by 1 plus some rate. And I know that I'm going 19 years later. So I'm going to do equals my final amount, which is 8.75. Now notice here it says algebraically. And so because of that, we need to actually deal with this using algebra, not just putting this into y1 and that into y2. So I'm going to start by getting this part alone. So divide both sides by 1.25. And that comes out to be 7 equals 1 plus r to the 19th. Now, I know that this almost looks exponential, but notice my unknown is not the exponent. My unknown is in the base. So to undo the 19th power, we are going to, let me change colors here, take a 19th root of both sides. And so this gives me the 19th root of 7, which is 1.078 dot equals 1 plus r. And that gives me that subtracting 1 from both sides. R equals 0.1078, blah, 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 blah. Notice, don't round. You should be copying those all the way out. And so that's going to give me a rate of growth to the nearest percent of 11%. All right, next one. The speed of a tidal wave S in hundreds of miles per hour can be modeled by this equation, where t represents the time from its origin in hours. Algebraically determine when S equals 0. So when S equals 0, I'm just going to put in S equals 0. So I will have 0 equals radical t minus 2t plus 6. And I see jumping out to me that this is a radical equation. So I'm going to start by getting the radical alone. So I'm going to add 2t to both sides and subtract 6 from both sides, and I will wind up with that. Now, from there, once my radical is alone, I can square both sides. And so the right side is just going to equal t. The left side, I'm going to actually need to multiply out 2t minus 6 times 2t minus 6. That comes out to be 4t squared minus 24t plus 36. And so now I have a quadratic. So I'm going to get it to equal 0. You can factor this. There's not a GCF, but you could do A times C. But when my numbers get this big, I'm actually going to do quadratic formula. So A equals 4, B equals negative 25, C equals 36. And so quadratic formula on this would be x equals negative b, so positive 25, plus or minus the square root of b squared. Notice I'm putting that in parentheses. Minus 4ac all over 2a. In other words, 25 plus or minus the square root of 49 all over 8. Now, luckily for us, the square root of 49 is a perfect square. So 25 plus or minus 7 over 8, which comes out to be 4 or 2.25. Now, I'm not quite done. I need to check both answers. So I'm going to plug them back into this, this original equation and see if they give me out 0. 2.25 does not, and so my final solution is just 4. Okay, next one. Again, more modeling, more word problems. A study was designed to test the effectiveness of a new drug. Half of the volunteers received the drug and the other half received a sugar pill. The probability that a volunteer receiving the drug and getting well was 40%. So let's write some stuff down. Probability of getting the drug was 0.5. Probability of no drug was also 0.5. And probability of getting the drug and getting well was 0.4. Now it says, what is the probability of a volunteer getting well given that they received the drug? So remember what we need to know here. The probability that they got well given that they received the drug. Well, what we know is we really care about only the subgroup that got the drug, right? So the subgroup is that, the people that got the drug. Now, of those people, you want to know how many people were well and got the drug, because they had to have gotten the drug, right? So this is really, 0.5 or half the people got the drug, and 0.4 got the drug and got well. And so that probability in general is 0.8. Okay, let's look at the next one. A student created a model for the population where P is the population in thousands, D, decades. That's going to be important, okay? Another student, Ella, wants to use this model to represent the population after Y years. Now, the first thing that I'm thinking is to go from decades to years, you are going to have to multiply by 1/10. And that's because a year is 1/10 of a decade, right? So I'm going to take my current base, which is 0.75. I'm going to erase that to the 1/10. And that gives me 0.9716416. And so I know that my correct equation should be C. Okay, so for this next one, a formula for work problems involves two people is shown here. And don't get intimidated by that because they're going to give us information. T1 is the time taken by a first person to complete a job. T2 is the time taken by a second person. And TB is the time it takes for them to both complete it. Fred and Barney are carpenters who build the same desk. It takes Fred 8 hours and it takes Barney 6. Write an equation. So it's starting by just asking me to write this equation. So I'm going to start by saying, okay, 1 over Fred's time plus 1 over Barney's time is 1 over, and I'm sorry, Barney's time is 6, 1 over their combined time. So that equation is really what I'm going to start with. Now, it says determine to the nearest tenth how long it would take them working together to build the desk. Notice it does not say algebraically. So you actually could just put this into y1, this into y2, and see where they intersect. But let's say that we combine some like terms. So this would be, this side adds to be 7 over 24 is 1 over TB. Cross multiply. So I get 24 equals TB times 7. Divide both sides by 7. And so to the nearest 10th, TB would equal 3.4. Okay, let's look at the next one. This one looks really intimidating, but let's kind of break this down. So a manufacturing company has developed a cost model, C of X, where X is the number of items sold in thousands. The sales price can be modeled by S of X, and revenue is R of X, which is X times S of X. Determine the company's profit, which is R minus C. So R here is X times S of X. So that's X times 30 minus 0.01x. And I'm going to subtract C, which is 0.15x cubed plus 0.01x squared plus 2x plus 120. Notice I put that in parentheses so that I remember to subtract out the whole thing, right? So now I'm going to start by distributing out my x. So 30x minus 0.01x squared, and then minus 0.15x cubed minus 0.01x squared plus 2x plus 120. And now we're just going to combine like terms, right? So like the 3x and the, negative 2x and negative 120, distributing that negative out. Those could combine, right? And so we're just going to wind up with negative 0.15x cubed minus 0.02x squared plus 28x minus 120. So really just a lot of algebra 1 in there. It's just that it looks a little bit intimidating. All right, let's go to the next one. So the value of a car based on its years in use is V of T. Aiden takes out a loan to purchase the car, which is Z of T. Z is dollars, and T is time in years. So we're going to graph V and Z on the same axis, and then we're going to state to the nearest hundredth where they're equal. So let me, through some TV magic, bring in the finished graph. Okay, so here I've got V of T in red, Z of T in green, and notice my axes are labeled. They're counting by a steady amount. All of that matters, right? Now, seeing where they intersect, I can see that it's somewhere right about here, but it does ask me to the nearest hundredth, so I don't want to just assume that it is at 2. So I would go second and then calc and then find that intersection. That's probably the easiest way to do it. And your intersection is going to be at 1.95. If you're struggling with doing that, go to my calculator help video and you can see how to do that more there. Now, what does that mean? At 1.5 years, because remember this x-axis is in years, or the t-axis, the value of the car will be the same as how much Aiden owes. Because remember, V is the value and Z is how much he owes, and we're talking about when those are equal. Okay, let's look at the next one. Okay, the function P of T, 110e to the 0.03922t, models population of a city, T years after 2010. So let's see what we know. From that equation, I know that my initial is 110. I know that it's continuous growth because of the E, and I know that the rate is 3.922%. So I've already got that. So let's see what these ask us. The current population is 110. That is not true. That's the initial population. So 1 is not right, so it can't be B or D here. Now then it says the population increases continuously. I know that's right because of the E, by approximately 3.9%. That's what this is saying, right? 0.03922. So C would be correct here. All right, next one. The graph below represents the height above the ground, each in inches of a point on a bike wheel during the ride in terms of t in seconds. Identify the period of the graph and describe what the period represents. Remember that period is the length of one full cycle. So when I look at this graph, I'm going to say, okay, so this starts at its maximum. It's going to go back down, come back up, and reach its max again. And that is 2/3. That's the wavelength, right? So your period here is 2/3 seconds. Now, what does that mean? That means it takes 2/3 of a second for the wheel to make one full revolution. Okay, so full revolution in the time of one period. All right, next one. Olivia decides to run a half marathon. She's looking at 2 plans. Jillian's is a 12-week plan. Josh's is a 14-week plan. The number of miles run per week for each plan is shown, which is arithmetic. Arithmetic should make you think that you're adding the same amount. Now, which one of these is that happening in? Well, I see that Josh's is going up, down, up, down, up, down, up. So I see that his is not arithmetic. And I can tell from the way the question is worded that one of them has to be. So I'm going to guess it's Jillian's, but let's see why. So this is 10, 11, 12, 13, 14, 15. That is increasing by a constant amount or a constant difference each week, right? So it's going up by a constant amount. Now, write a recursive definition. Recursive, remember that means recurring. That means depending on the term before it. So here, A1 would be 10. That's my first term. And then the pattern is to take the term before it and add 1. All right, next one. The voltage used by most households can be modeled by a function, sine function. Maximum is 120 and there are 60 cycles every second. Which equation best represents the voltage? So all of these have the same amplitude. That 120 does not really help us. So let's look then at this 60 cycles every second. So what I know now is the period is 1/60th of a second, right? 1/60th of a second. And so the B value should be 2 pi over the period, which is 2 pi times 60, which is 120 pi. And so that means it's answer choice D. All right, one more trig graph. The resting blood pressure of an adult patient can be modeled by the function P of t equals 24 cos 3 pi t plus 120. Graph it. That's all it says. And notice it's on the domain from 0 to 2. And they've already labeled these for you. So I know that that's 2. And then you can count up by whatever here. But I'm going to count maybe by 5s. So this would be 100. This would be 110, right? And we could keep going up. So let's start with what we know here. I know that A is 24. I know that the midline is y equals 120. And it's a line. So I have a y equals there. The period, or the length of a wave, is going to be 2 pi over 3 pi, which is 2/3. So I'm actually going to start with that on my graph before I do anything else. At 2/3, that will be one full wavelength. So if this is 1, 2/3 of the way would be right here, right? So what that tells me is every 4 boxes, I'll have one full wave. So there's 1, and then 4 more would be a second, and then 4 more would be a third, right? And so that right there will give me 3 full waves. So I'm keeping that in the back of my mind. Now, let's figure out what else we know. We can find the min, and we can find the max. So to get the minimum, you're going to start at the midline, and you're going to subtract the amplitude, and that gives me a min of 96. To get the max, you're going to start at the midline and add the amplitude. That gives me a max of 144. And now I'm just going to graph those and see what that looks like. I'm going to bring in the finished graph just for the sake of time right now. So a little bit of TV magic here. Ta-da! So see, it ends at 2/3, right? That's one full wave. And we're going max, midline, min, midline, max. Remember, this is a cosine curve, so it should start from its maximum. And also, guys, please remember that you have a calculator. Don't be afraid to use it. Don't be afraid to look at it and see what it should look like. Use the table to graph. but it's going to make it a lot easier if you actually know how to figure out what's going on here. Okay, last question. The breakdown of a drug is represented by N of T. N is the amount left in the body. N sub 0 is the initial dose, R is the rate of decay, and T is the time in hours. Patient A is given 800 milligrams of a drug with a decay rate of 0.347. Patient B is given 400 milligrams of a drug with a decay rate of 0.231. So A asks us to write an equation for each. B says graph. C says when will patient B begin to exceed patient A? In other words, we need to find the tipping point where they're equal. And then part D asks, when will we have 15% left? And notice it doesn't specify. You need to solve that algebraically there. So again, TV magic, I'm going to bring in the finished graph and we'll take a look at this. Okay, so for A, initial is 800, e to the negative 0.347 t. Remember, it's decay. That should be negative. And in this equation, it was negative. B is 400 e to the negative 0.231 t. And so I've graphed those, right? Notice that I have labeled it by a nice even amount on each axis, and I've labeled what's B and what's A. Now, it's a little bit hard to tell where they're equal. I know it's somewhere in here, but it's hard to just tell from the graph. So it says to the nearest hour, when will one exceed the other? And so you could use the table here. Nearest hour isn't terribly specific, but you also could put A of t in y1, B of t in y2, and then do second calc intersect. And that's probably going to give you your best picture of where they actually intersect. It comes out to be right in between 6 and 7 hours, closer to 6. All right, and then the last one, the doctor will allow another 800 dosage for patients when 15% of the original dose is left. Determine to the nearest tenth how long they will have to wait until they receive 800 milligrams. So I'm going to set this equal to 15% of 120. Now here you are welcome to just put one side in y1, the other side in y2, and go from there. But let's do this algebraically just to make sure we've got it. So divide both sides by 800, convert to a log, and remember log base E is ln, and then divide by negative 0.347, and that would be 5.5 hours. So guys, that is our last live stream. That is all things word problems, and you guys are ready to rock this. So send me questions. Refer back to any of my other live streams if you need to. Tomorrow we will be back for one last madness, mayhem, mixed up fun fest. And I will see you guys later.